people. Yeah, before I start the material, let me introduce myself. So my name is Wildan Pratama with NPM 23312024. So the material is when brute force becomes a problem and how performance worsens as input size grows. So the first one is, what is a brute force algorithm? A brute force is represent the most straightforward approach to problem solving. Systematically try even possible solution when finding the correct one. So this exhaustive methodology guarantees that if a solution exists, you will find it, but often at tremendous completion cost. So just like simple implementation and guarantee success and computational inefficiency. Now the core issue, how performance deteriorates. The critical weakness of brute force emerges as input size increase. So the most brute force algorithm exhibit time complexity that grows linearly with input size, but many grow far worse, so doubling or even factoring. For example, a simple linear search check each item sequentially, so resulting time complexity. However, more complex problems like subset sum or traveling salesman problems experience exponential growth, reaching or factorial complexity. This means that adding just a few more elements to your input can transform a manageable computation into impossibly long calculation. So for password cracking, a dramatic real-world example. So password cracking in brute force perfectly illustrated how quickly computation becomes infeasible. The number of possible combination grows exponentially with each additional character, making longer password. So 6 character of password is low-case letter only combination to try. So if you want to use 8 character password is over 200 billion combination and vastly become attempts required. And for exponential growth each added character multiples total combination by 26. Next we have real-world scare. So hardware versus brute force. Modern computing hardware is remarkably powerful, like high-end graphic processor like the NVIDIA RTX 4090 can execute billions of cryptographic guesses per second. Yet even this staggering computational power cannot overcome the mathematical reality of brute force scaling. Strong password of the 12 or more characters remain particularly uncrackable through brute force. So because the hardware isn't fast enough, but brute force time growth is simply aggressive. So a 12 character password with mixed case and number creates a search space so fast that even billions of attempts per second would require centuries of continuous computation. So GPU power of RTX 4090 is billions of guesses per second across parallel processor, but in reality check is 12 plus character password still require impactful in frames measured in centuries. So the combinational explosion in optimization problems, especially problematic in option scenarios when you must evaluate combination of multiple variables. Consider a particle engineering problem with just optimization variables, each requiring evaluation across multiple intervals. So with 200 intervals for the first variable and 1000 for the second and 200 for the third, the total combination is reached 40 million calculation. As variable increase or resolution improves, this explosive growth renders brute force completely impractical. So real-world engineering problem often involve dozen variables, making pure brute force insurement physically impossible with any reasonable time frame. So yeah, visualizing the impact, time versus input size. So this is the contrast between different time complexity become starkly apparent when visualized linear search grows opportunely, doubling the input, roughly doubles computation time. However, the exponential algorithms use subset, sum or traveling salesman problems exhibit dramatically different behavior. Even modest input increase trigger massive computation jump. At small input size, exponential algorithms may complete in milliseconds, but as input grows from 20 to 30 or to 40 elements, execution time jumps for seconds to hours or to years. The visualization powerfully demonstrated why brute force is breaking so down quickly. And now the conclusion is knowing when brute force works and when it doesn't. Brute force is serves specific purpose and context, so they excel for small input, where guaranteeing contrast matters more than speed, and for simple problems where implementation simplicity is valued. However, the fundamental scaling limitation make them impractical for large input and complex real-world problems. Understanding this limitation is crucial for effective algorithm design when brute force becomes computationally infeasible, so developer must pivot toward smarter approach. And dynamic programming for greedy algorithms, heuristics, or machine learning technique, whatever. So the journey from the brute force is optimized solution represent one of computer science core challenge, balancing the simplicity with scalability and guaranteeing the correctness with practical feasibility. So recognize when brute force breaks down this first step forward, designing solutions that actually work at scale. So why we use brute force? So it's just for small input and guarantee correctness needed, simple implementation priority. For the avoid brute force, so it was just large inputs and the performance is critical, scalability essential, and real-world production system. So we have a better alternative side that will be optimization algorithms, dynamic programming, heuristics, and specialized data structures. Okay, that's all for the materials when brute force becomes a problem. I hope you guys enjoy my video, and don't forget to like, share to your friend. I'll see you in the next video.
Waktu ditinggalin, ku gak mau kalah.